Welcome to Maths with EJD. We continue with coordinate geometry. And from this video up to the next three, I think, we'll be talking about equations of lines and different aspects of that, right? So for this first part, it's about equations of lines, and we'll start with line representations. We had started out this playlist talking about the fact that René Descartes gave us the privilege of being able to merge algebra and geometry because we can actually represent a point on a Cartesian coordinate system. Cartesian, his name is René Descartes, right? So Cartesian is from Descartes, Cartes. So the fact that we can represent a point, you know, on the Cartesian coordinate system, and then when you join 2 points together, you get a straight line. And because you can join those 2 points together like that, you can then form an equation based on those 2 points. And that is the kind of thing we're looking at here. So equation of lines, talking about line representation to start with. Okay, so here, uh, lines in coordinate geometry can be represented in I mean, lines in coordinate geometry can be represented in various algebraic forms depending on the available information. So, there are some key information about a straight line. So, that depending on which one you have, right, you can get a particular form of that line. So understanding these representations allows us to handle problems involving straight lines effectively. So let's go straight and talk about line representations. So we have a slope-intercept form of line representation to start with. So the slope-intercept form is of the form y equals mx plus c, where m is the slope of the line, c is the y-intercept. That is the value of y when x is equal to 0. Okay, so if you have the slope of a line and you have the y-intercept of a line, then you can easily represent the line in the slope-intercept form, basically. So that's why what we mean by the kind of information available. So if you have slope and intercept, you can simply just write down the equation of the line. As you see in this example right here, it says find the equation of the line with slope m equals to passing through the y-axis at 0, 3. Okay, so the solution is simply, of course, okay, let's go and use Desmos to our advantage here. So I click on this and we have Desmos live. Okay, so the graphing thing. Yes, so we come here now. So we know the slope already, that is m already taken care of. Then for this intercept now, so the 0.03 is going to tell us that. So we have this now 0, 3. Okay, so it means that and you already know that the y-intercept is the value of y when x is 0. So when x is 0 here, y is 3, that's the y-intercept. So simply we just know that m is equal to 2 for slope, c is equal to 3 for intercept, and then we can simply write the equation of that line as y equals 2x plus 3. So straight to the point. So I didn't even have to show this on the graph even. Like once you do that, see x is 0, y is whatever y is, that's the y-intercept. And then together with the slope, you can easily form the slope-intercept form of that equation. Okay? Then apart from the slope-intercept form, we have the point-slope form. So the point-slope form is this. So if a line passes through a point x1, y1 and has slope m, the equation is y minus y1 equals m into x minus x1. So, previously, if you had slope and y-intercept, you can just fix up the value of m and c in y equals mx plus c. But in this case now, you have a point through which the line passes and you have a slope. So it's a point now, not just the y-intercept. So in that case, you have another approach where where you have y minus y1 equals m into x minus x1. Okay, so find the equation of the line with slope m equals minus 1 over 2, passing through the point 4, 5. Okay, so I guess I want to go to the worksheet this time around. So let's go for that. Um, okay, I open a new one. You have slope m. So we have m for this Now we have m to be minus 1 over 2, and then we have a point it's through which the line passes. I think that's 4 comma 5, right? So that's 4 comma 5. Okay, good. So the question is, we need to find the equation of the line, right? So to find the equation of this line now, so you can call this x1, y1, and that's all we have. So the line has this slope and it passes through this point. And of course, from what we already know from the idea of slope, we know that slope is change in y all over change in x, right? So in that case, we can say m is a particular y minus y1 all over a particular x minus x1. Uh, assuming that, uh, assuming, assuming the line passes through x comma y. Okay, so we can then have y minus y1, x minus x1, and that is the value of the slope. So now we have minus 1 over 2 equals y minus y1. So that's y minus y1 now is 5 all over x minus x1, which is 4. So here we can multiply through by 2, we can multiply through by 2. Or better still, we can just have minus 1 over 2 into x minus 4, and that is equal to y minus 5. Okay, we can have it this way, and with that now, we can say this is minus 1 over 2x plus, minus and minus is plus 2, like that. And that is y minus 5. So that way, we can say this is minus 1 over 2x plus 2 plus 5 equals y. So y is equal to minus 1 over 2x plus 7. Okay, minus 1 over 2x plus 7. So at the end of the day, you see this one still comes back to that form where you have y equals, where you can say the slope, of course, can be read out to be minus 1 over 2 if you compare it with y equals mx plus c. And the y-intercept in this case now is simply this 7. Okay, so of course, we can still go ahead and multiply through by 2. But if you want to see the slope and the intercept, this is the best way to have it. But we are going to see some other forms later, like some kind of general form. Okay, so that is the point slope form. So we already had the slope intercept form. Now this is the point slope form. You have a slope, you have a point through which the line passes. What if you have the 2-point form? The 2-point form. So the 2-point form in this case talks about the fact that a line is passing through points x1 and y1 and x2 and y2. All right. So here now you don't have slope, you don't have intercept, but you have 2 points through which the line passes, two given points, not just arbitrary points xy that we needed to use in the other case. In the last problem I solved. So in that case, now you just have y minus y1 equals y2 minus y1 over x2 minus x1 equals x minus x1. Okay? Now, why do we have this? So let's solve this problem. Find the equation of the line passing through 1, 2, 3, 6. 1, 2, 3, 6. Okay? So we have point A, 1, comma 2, point B, 3, comma 6. Okay. If you like, you can plot it on a graph if you like. So thankfully, everything is in the first quadrant, all positive. So this is y, this is x. So let's say uh this is 2, this is 4, this is 6, and here we have 2, 4, 6. So there's no point if you don't have to plot it, but if you plot it, it's not a problem. So this is point A now. This is 1, comma 2. 3, 6. You have 3 against 6 here. Something around here has B 3, comma 6. So this is the line now. So we need to find the equation of this line. Now, the whole idea is everything is still connected to the slope at the end of the day. So you can say this is x1, y1, x2, y2. So then you choose, so you choose an arbitrary point, choose an arbitrary point, x comma y. Choose an arbitrary point x comma y. And then going by the idea of a slope, y minus y1 over x minus x1 is the slope. And it is also true if you do y2 minus y1 all over x2 minus x1. This is slope, true. This is also slope. And because of that now, x minus x1, right? So if you equate the two together, you are correct because they are both slopes now. So based on this, we can then go ahead and say the arbitrary y minus y1, which is 1, all over the arbitrary x minus x1. Sorry, y1 should be 2, sorry. y1 is 2 because x1 is 1. So 1 comma 2, that's x1, y1. Then the arbitrary x minus x1, which is 1, and that is equal to y2. So y2 is 6 minus the arbitrary, no, the y1, which is 2, all over x2. x2 is 3 minus this x1, like this. So you have y minus 2 all over x minus 1 equals 6 minus 2 over 3 minus 1. So you have y minus 2 over x minus 1 equals 6 minus 2 is 4, 3 minus 1 is 2. Okay, so here you can, this is still y minus 2 over x minus 1 equals 2. So with that, now we can tidy things up. So we can multiply 3 by x minus 1. So you have y minus 2 equals 2 into x minus 1. So like you can cross multiply. So 2 multiply x minus 1. So we have y minus 2 equals 2x minus 2. So in that case now, we have y equals 2x minus 2 plus 2. That's transferring this to here. So this cancels out. And finally, we have y equals 2x. So if you want to read this off now, you know that the slope is 2, and then the y-intercept is 0 because we don't have that y-intercept here. So that is so the equation of a straight line, when you have the 2 points, when you have any 2 points through which the line passes, that's how to get it. So we have seen the slope intercept form, we've seen the intercept, and we've seen the uh slope intercept form, we've seen the point slope form, and then now we have seen the 2 point form. Okay, so let's go ahead and look at the intercept form. So for the intercept form now, uh, if a line cuts the x-axis at A and the y-axis at B, then its equation is x over A plus y over B equals 1. As simple as that. Okay, so we want to find the equation of the line with x-intercept 4 and y-intercept 6. So passes through uh, x-axis at A and y-axis at B. So we have 4, 6. So it passes through x at 4 and passes through y at 6. The equation is simply x over A plus y over B equals 1. Simple. So we come back here. All right. So for this intercept form now, so imagine you have this now. So let's say this is 2, 4, okay, on the x-axis. This is the origin as usual. This is 2, 4, 6 on the y-axis. And then want to find the equation of the line with intercept, with x-intercept 4. So it passes through this line point, and y-intercept 6, this. So this is the line now. So you have this line. So this has been so made easy that you can just say the equation of the line is x over A, the x-intercept, plus y over B, the y-intercept, and that is equal to 1. So you have x over 4 plus y over 6 equals 1. To multiply through by the LCM of 4 and 6, that's 12. So you have LCM of 4 and 6 is 12, right? So you have x over 4 times 12 plus y over 6 times 12 equals 1 times 12. So if you've forgotten how to find the LCM of 4 and 6, you have 4 is 2 times 2. 6 is 2 times 3. Okay? The LCM will simply be pick the highest number of 2. That's 2 times 2. And, because this is only 1 to 2, two twos will take care of this. Then this only 3. You have this 2 times 2 times 3 is now 12. That's how to find LCM. That's how we did this. So 4 here is 1, 4 here is 3, 6 here is 1, 6 here is 2. So you have 3 times x, 3x, 2 times y is 2y, and that is equal to 12. So this is the equation of that line. But of course, if you want to write it in that y equals mxe form, so that means you still have 2y equals 12 minus 3x. All right? Or better still, 2y equals minus 3x plus 12. So if you divide 3 by 2, y is equal to minus 3 over 2x plus 12 over 2, which is 6. Okay? So here now we see that the slope m is minus 3 over 2, and the y-intercept is 6 in this case. Of course, which is correct with what we started with, like that. So that is the intercept form right there for you, the intercept form. So having done that, we now want to see what we call the general form. So there's a general form. So the general equation of a line is simply ax plus by plus c equals 0, where a, b, c are real constants and a, b are not both 0. So all the equations we've written so far, we can write them in this general form. So like I can go back to all the ones we've done previously. So I can go back to all of them and then write them in the general form. So okay, yeah, this is the first one today. So we got this. So to put this in the general form, right? Of course, you're still going to take care of all that. So you have to multiply through by 2. So you have 2y equals minus x plus 14. So in the general form, you simply have, ax plus by plus c equals 0. So in that case now, you can transfer this. So you have x plus 2y minus 14 equals 0. That's the general form in that case. So, so for this other one, the general form will simply be, you can say this is, y minus 2x or 2x minus y. So the general form, just rearrange 2x minus y, and that is 0. That's the general form in that case. Then coming here, since we already have this, we just need to rearrange. I'll just say 3x plus 2y minus 12 equals 0. That's the general form. I think that's the last one. Yeah. So that's how to put things in general form. So you can easily convert from one form to the other. So I think that's the next thing we need to work with. Conversion between forms. So, I mean, I've uh, inadvertently done this conversion from time to time. Each time I get a form and I put it in that form where you can have it in a slope-intercept form. That's part of it. So if you want to convert from slope-intercept form to general form, all you just need to do is rearrange. So y equals mx plus, it simply becomes mx minus y plus c equals 0. That's all. Then from point slope form to general form, you have y minus y1 equals m into x minus x1. So you simply just have mx minus y plus y1 minus mx1 equals 0. Then from intercept form to general form, so you have x over a plus y over b equals 1. So you just rearrange and you have bx plus ay minus ab equals 0. So let's look at practical examples now. This one says convert the slope-intercept form y equals okay. We want to convert the slope-intercept from y equals 3x minus 7 into general form. Simply, you have y equals 3x minus 7. So just transfer y here. So you have 3x minus y minus 7. And, since y is no longer here, so you just have 0. So that's simply the same thing as 3x minus y minus 7 equals 0. Easily. Then here, we want to convert x over 2 plus y over 3 equals 1 into the general form. First of all, you multiply through by the LCM, which is 6. So x over 2 times 6, 3x. Y over 3 times 6, 2y. 1 times 6, 6. So the general form will simply be 2x plus 2y, 3x plus 2y minus 6 equals 0. So you transfer everything to the other side and then equate to 0. That's the general form. So in summary, we have this summary. So look at the summary table of line equations like this. So the slope, you have the slope intercept from y equals mx plus c. The key parameters, m is slope, c is y-intercept. Typical usage, when slope and y-intercept are known, when you know slope and y-intercept, just fix them up, right? For this point slope form, you have y minus y1 equals m into x minus x1. So yeah, the key parameters, m is slope, x1, comma y1 is the known point when slope and 1 point are known. Then for 2 point form, you have y minus y1 equals y2 minus y1 over x2 minus x1 equals x minus x, multiplied by x minus x1. Well, technically, it's actually y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So we just multiply both sides by x minus x1. So this just remains y minus y1 equals y2 minus y1 over x2 minus x1 into x minus x1. So the 2 points, you have two known points, x1, y1, and x2, y2. So when 2 points on the line are known, then you can use this 2-point form. For the intercept form, you have x over a plus y over b equals 1. So a is the x-intercept, where the line cuts the x-axis. B is y-intercept, where the line cuts the y-axis. So the typical usage is when the intercepts of the axis are known. Then the general form is ax plus by plus c equals 0. So a, b, and c are constants, but a and b must not be 0. C can be 0, right? But a and b, one of a and b should not be 0. So the typical usage is a standardized form and useful for algebraic manipulation. So you have practice questions here. As usual, we have 10 of them. You can easily run through all that. So write the equation of a line with slope 2 and y-intercept minus 5. You know, that's easy. That's just y equals 2x minus 5. Easy. Then find the equation of the line passing through the point 3, 4 with slope minus 3 over 2. So you know that'll just be minus 3 over 2 equals y minus 4 over x minus 3 easily. And then you just simplify. Determine the equation of the line passing through the point 1, 2 equals 4, 8, 1, 2, and 4, 8. Of course, you know that'll just be y minus 2 over x minus 1 equals 8 minus 2 over 4 minus 1. You simplify. And then you take care of this whole thing like that. All right? So if you want, imagine this 5, you want to convert it to general form, first you multiply 3 by 3. So you have 3y equals minus x plus 2. So you can then transfer x to this side now. So you have x plus 3y minus 2 equals 0. That will be the general form. So you can take care of the rest like that. So with this, I come to the end of this interesting video on equations of line, talking about line representation, how to represent a straight line. All right, let me know how helpful this is for you. And if there's something you'd like me to try, feel very free to let me know. All right. And then, of course, if you have subscribed already, I thank you for that. If you have not subscribed, go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. Having subscribed, you can want to take it a step further and become a member of the channel by clicking on join with 3 levels of membership and special privileges, right? Ultimately, don't forget to comment, like, and share so that more people can have access to this video and other content I have on this channel. Till I come your way again, keep doing maths right. Bye.